Hello guys, let's do some Leetcode today. So today's question is count unguarded cells in the grid. Okay, this is the question of for today. Here we are given. Let's read the question first. You are given two integers m and n representing zero indexed m cross n grid. We are also given 2D integer arrays, guards, and walls, where the guard I at row and column I and wall is at row j and column j. Represent the positions of the ith guard and jth wall respectively. Okay, so the constraint given is the guard can see every cell. The guard can see every cell. Okay, and the four cardinal directions north, east, south, west, starting from their position unless obstructed by a wall or another guard. Okay, so the cell is guarded if it is at least one guard that can see it. Return number of unoccupied cells. Okay, so the main objective is return the unoccupied cells. So let's take an example. Let's take an example. As you can see here, in this matrix, the guard is standing at a zeroth column, and you can see at positions like here and here because it cannot see it here because here's a wall. Okay, at 0 1, and then let's go to second guard. So at the second guard, we he can see here is here, and you can see go up, left, right, and down. So he cannot go up because there is a wall again. He can go left. So it was already guarded. So once more it's guarded. Now it can go down, and this both cells is now guarded. We can mark it. It's just guarded. Okay, and he can also see here. Okay, so these two cells are also guarded because here is a wall, so it will not pass through it. Okay, then let's go to third guard. That is here. He can see up, left, down, right, and down. He cannot see the wall because he cannot go right because it's wall there. Okay, so let's mark it. If you're marking it with the color, so now the left out parts are this green part, this green part, this green part, then this green part, then this green part, this green part, this green part, this green part, and this green part. So I have to return this 1, 2, 3, 4, 5, 6, 7. So here we can directly use a BFS approach or DFS. We can use any of the one of the approaches. Like let's go with the BFS approach because it's O of one complexity because we can just change the position in place. We cannot do that in DFS. So let's go with the BFS first. Okay. So let's create a matrix here. Okay, and here is the guard. Here is the wall. Then here is empty. Then here is the guard. Here is the wall. Okay, and let me erase. Yeah, wait a second. Yeah, let's make a matrix. Here is the guard. Then here is a wall. Then below wall there is a guard. Then here is a wall. Then here is a guard. Okay, and here is a wall. And other all cells are like we can mark it as 0 because for now it's unvisited. Okay. So first we will go to the first guard here, this G, and we will traverse the right, left, right, top, and down. We cannot go top because it's the topmost position. Cannot go left because it's the leftmost position. In the right part there is a wall, so we cannot go there. So we can only go down here. So we will just make it as so we can just change it as 1 that is guarded. Same with this thing because it's 0 and above we can traverse it, so it will be 1. Then now let's go to the second guard. Now it's complete. So let's go to the second guard. This one. It cannot go up because there is a wall. It it can go left, but it's already visited, so we will just ignore it. We can go down and we can go right. Okay, so let's go right first. So we will traverse it till we get a wall. So here it will convert, change it to 1, then again this to 1, and we will stop it because there is a wall here. Okay, and then we'll go down now. Down there is 0, we can convert it to 1, and then it's the matrix ended, so we can just stop it. Then we go to third guard, and the third guard we can see uh, yes, and in third guard we can see that yeah, wait a second. One. Yeah. Now guys, our third guard, he is here, and we can go up, left. We can go left because there is a wall. We can go right. We cannot go down because it's the last position. We can go up because there is a 0 here that is unvisited. So we will directly convert it, this 0 to 1, because we have traversed it. This is 1, so ignore it. Then this was 0, so make it 1. Then go to the right of the guard. Here it is 0, so we can go make it 1. Make it 1. Yeah. And this dance. Now we just have to count how many zeros are there in this matrix. That is 1 and 2. So answer will be 2. So let's see with the code. So let's solve this question with, yeah. So initially we will make a grid for storing all the things, because we got guards here, walls here, and the guards here was a number of rows and number of columns here. Okay. So let's make a grid that is of 0. Like every node is not visited now, for now, or not guarded, not world. Okay. So we will just mark it and make it a matrix. Then star n for number of columns. Then underscore in range m for making it, for making a matrix. Then we will iterate through the first. Let's iterate to the walls. We will add the walls first. Okay. Then j in range, let's make it not more walls. Okay. Then we will just add it grid I, and for column j equal to yeah, let's make a thing like that is, if it's unguarded, wait a second, unguarded, or it's guarded, or there's a guard there, or there's a wall there, we will mark it. Let's make it 0, 1, 2, 3. Let's give it an index so it will be easy for us to identify it. So there is a wall at here, so we will make it a wall. Okay, there will be 3 here. Then we will add guards for there. Okay, I comma j in guards grid. Now we will add guards at the respective position in the grid. I j equal to guard. Okay, so now let's create a DFS function. So BFS function, sorry, BFS, that takes row and column. And now let's go upward first. Okay, for I for let's keep it row. For row in range, let's go up on the from the following guard. The guard is seeing up. Let's take this part first. Seeing up, and row minus 1, because we don't have to process that input, that guard, so we'll reduce it till minus 1 and minus 1. Okay, so we will check if it's obstructed by any wall or guard. Okay, so grid of row and that particular column equal to wall, or that grid, row and column equal to some guard. Okay, then we will just break it because we don't have to, we cannot go up further from that position. So if we cannot find any guard or wall, we will just add the, like it's guarded now. Okay, so grid row and column is now guarded. guarded. Okay, then we will see down, seeing down. So let's just copy this to reduce our work and paste it. And instead of this, we will make it row plus 1 comma m. We don't have to process that node, and further node below it we need to see below it until m, and it's the same logic. Then for columns we can just copy this code, and now we can just check seeing left. Let's check left and just paste it. Column minus 1 comma minus 1 comma minus 1. Okay, and this is the same row and C. Let's make it just, I'm trying to keep it simple, so making it. This is the same logic as above, just changing the variable names. And just paste it again, make it column, row, C, row, C, C, row. Okay, and till n, we will take it. And done. Now we have completed BFS thing, and this is doing it in place. So it has O of one time complex, space complexity. Okay, same, right. Right. Okay. Then we will go now. Let's call that BFS function. Okay. So for I comma j in guard. Okay. So let's call the the position to iterate it contain by a breadth. Okay. So guards of I on j equal to, oh sorry, my bad. Let's call it. So BFS of, let's make it ij instead, row and R and C, so it will be better to see row and column. And then just now, if we print it, print suppose grid, okay, and just return some function just to verify it. Okay, just check it. Okay. Oh my bad, this was a problem. Yeah, as you can see that, see this. We give the guard the second index. There is a guard here. There is a wall here. Zero means it's not visited. One means it's guarded. So here it is one, as you can see. Then zero zero, like it's not visited here, as we can see here and here. Okay. So now we just have to iterate how many zeros are there in our matrix. Okay. Let's create a variable called answer, that is zero, and let's return answer. Then for r in range uh, m, and then for c in range n, if our grid of r and column equal to unguarded, just increment our answer, so we'll get a number of zeros here and just run it. Yeah, as you can see, 7 and 7. Then let's submit it. Yeah, as you can see, it is pretty, I mean, optimized. And as you can see, the time complexity will be O of m into n, because m is the number of columns and n is number of rows. Okay. And memory is O of 1 because we are doing it in place. Okay. It's wrong. It's showing it wrong. But it's O of 1 because we are not changing anything. We are just adding it. So, so please like, share, and comment if you have any improvement, because I am new to this. So there will be some problem in my voice in speaking. Thank you.